Cement is foundational to a well's life cycle, and a high-quality cement sheath can prevent problems ranging across the spectrum, from gas migration to casing failure. This video will explore the most common well cementing problems and some of the best ways to address them, starting with unwanted gas flow. Gas flow up the annulus after cement is pumped into place is a common but unwanted event. Annular gas flow occurs when three conditions are met simultaneously, which are shown in this diagram. Removing any of these root causes can prevent gas flow, and proper centralization of the casing string is an excellent solution. A good centralization program assists with coverage of the full annular cross-section by cement. Zonal communication is when water or gas from one zone travels into another. Mud channeling, casing corrosion, and poorly bonded cement can all create pathways for water and gas to migrate between zones. The best method of prevention is to eliminate the flow path by achieving zonal isolation through full mud displacement. Stage communication during stimulation describes when stimulation fluids travel to a prior stage. Prevention methods include spacer fluids that are compatible with both the mud and cement, and a high-performance slurry to seal gaps in the annulus. Poor mud displacement efficiency is defined by the percentage of the annular cross-section that is covered by drilling fluid instead of cement. Position A in this diagram shows mud in the narrow side of the annulus and is the most common area for poor displacement. Areas B, C, and D in the diagram also show possible displacement locations and types. A centralization simulation can be used to determine the optimum placement for centralizers. Cement failure will occur if the stresses placed on the cement exceed its strength. Contamination, poor density control, and corrosive fluids in the annulus can compromise the cement strength. Cement failure can be prevented with a slurry design that considers the various loads the cement will experience over its full life cycle. Observing a higher rate of flow at the return line than the pump rate can indicate an influx of formation fluids during cementing. The key to preventing fluid influx is the use of flow checks before cementing and maintaining annulus pressures above the formation pressure. Lost circulation is observed when returns are not coming back to the surface as a result of fluids lost to the formation. Preventing lost circulation involves managing the drilling fluid density, and remediation can be achieved by adding lost circulation material during the drilling process. Excessively high pump pressures during cementing indicates poor pumpability. To prevent this from occurring, there are many things to consider, such as good casing design, the mud removal plan, and a tailored slurry design. A wet shoe track occurs when the displacement fluid does not stop inside the casing, entering the annulus and creating unwanted communication paths. The primary method of preventing a wet shoe is to ensure that all the various considerations that affect the displacement volume are carefully calculated. Lifted casing is when the casing rises out of the hole or lifts off the slips or elevators. Casing strings lift out of the wellbore when buoyancy and pressure forces are greater than the weight of the casing. The best method to preventing casing lift during the cement job is to slow down the pump rate. Low top of cement is typically the result of other cementing problems, such as lost circulation. A minimum volume of cement slurry should be determined, and contingency plans should be developed in case the minimum volume is not met.